Welcome to AT Math Academy. Topic for today is matrices. We are going to look for 3 by 3 matrix, 3 by 3, and we are going to understand what exactly is a cofactor of the matrix. So let me take an example of the standard matrix A, first row, first column. I'm naming it as 1 1, which indicates 1 1 here indicates first row and first column, and this is first row second element 1 and 2, and first row third element, second row first element 2 and 1, second row second element is written as 2 2, second row third element, and third row first element, third row second element, third row third element. So this is the standard 3 by 3 matrix, which has 3 rows and 3 columns. So let's understand the cofactor of this matrix. So cofactor can be found out using the formula of -1 times I plus j multiplied with minor of I and j. So let's talk in detail about it. -1 to the power of I plus j is nothing but this indicates again row and this indicates column. I is for row and j is for column. Same here. This is for row and this is for column. And this m here is nothing but minor. Finding the minor means we eliminate the row and column of the matrix. Particular row and column is eliminated, and then we find out, after eliminating, we find out determinant of remaining matrix. So let me explain that for you. So taking m of, so let's find out the cofactor for first row and first column A11. So for doing that, first row first column A11 cofactor. So I'm going to write it as cofactor of A11. First row first column I and j. This can be written as -1 to the power I plus j and minor of I and j, which is -1. I is equal to 1 and j is again equal to 1, and minor is the determinant of the matrix, eliminated the row, first row and first column. So this is my first row and this is my first column. So I am eliminating my first row and first column. Then the remaining matrix would be this one. So I'm going to take the determinant of remaining matrix, which is these elements here: A22, A23, and A32, and A33. Okay. So this is how you find out the minor for the I and j of first row and first column. After removing, we are left out with this matrix, and for finding the determinant of this matrix gives us the minor. And -1 to the power of 1 and 1 is minus 1 to the power 2, and determinant for this is, in my earlier videos I have shown you that determinant can be found out by multiplying the diagonal elements and subtracting the product of the diagonal elements. So it can be written as A22 times A33 minus these elements A23 times A32. So this is the way that you find out the cofactor for the first element. So similarly we can find out the cofactor for all the other elements. So let me show for the second element. So cofactor of A first row second element, which is minus 1 to the power I plus j. My I value is 1 and j value is 2, so 1 plus 2, and my minor would be first row and second column should be eliminated. So minus 1 to the power 1 plus 2 is 3, and minor of 1 and 2, which means first row and second column is this one. This one should be eliminated. Then the remaining matrix would be first row and second column eliminated. Remaining would be this one, this one, and this one, and this one. So let me show you here clearly. So I'm going to rewrite the matrix here for you. A11, 1, 2, 1, 3, A21, 2, 2, 2, 3, and A31, 3, 2, and 3, 3. Okay, this is our given matrix, and I'm going to eliminate my first row and what second column. So I'm left over with the submatrix with elements, these 4 elements. So my minor of the matrix would be determinant of these 4 elements: A21, A23, A31, A33. Okay, so this gives me the answer as minus 1 times determinant of this is product of these diagonal elements, which is A21 and A33 minus A31 and A23. So when you observe, we have a clear formula of, like, clear formula can be written for each of the elements, like for 1 1 and 1 2 and 1 3. So it will be minus 1 power 1 plus 1, and for 1 2 it will be minus 1 power 1 plus 2, and minus 1 power 1 plus 3. Likewise for the other elements of A21, 2 2, and 2 3, 2 1, 2 2, 2 3. So I can write it as minus 1 power 2 plus 1, and minus 1 power 2 plus 2, and minus 1 power 2 plus 3. Similarly, I can also write it as for 3 third row first element, third row second element, third row third element. I can write it as minus 1 power 3 plus 1, minus 1 power 3 plus 2, minus 1 power 3 plus 3. So let's evaluate it. Minus 1 power 1 plus 1 is minus 1 power 2, which is 1. Minus 1 to the power 3 is minus 1 times minus 1 times minus 1. Anything to the minus 1 to the power odd is minus 1. And here we have minus 1 to the power even number 4, so it will be 1. And here it will be again odd, minus 1 to the power 3, which is minus 1. Here minus 1 to the power 4, which is 1, and here it is again minus 1, minus 1 to the power 5. In minus 1 to the power 4 is 1, minus 1 to the power 5 is minus 1, minus 1 to the power 6 is 1. So finally the resultant cofactor matrix would be like each element 1, minus 1, 1, and second row it will be minus 1, 1, and minus 1. Third row it will be 1, minus 1, and 1. And these are the minus 1 to the power I plus j, and that those numbers should be multiplied with minor of the eliminated matrix. And as you all know, the minor can be found out by eliminating the needed row and column. Say suppose you wanted to find out the cofactor of A11, then you're going to multiply it with -1 to the power 1 plus 1 and minor of 1 and 1, which is this one over here. And if you want to perform the cofactor of A12, the second element, first row second element, then you're going to multiply -1 to the power 1 plus 2 and minor of 1 and 2. Minor of 1 and 2 means eliminate first row and second column and then find out the determinant of the remaining matrix using AD minus BC. So in that way, say suppose you want to find out the cofactor of this one, A33. So in that way, -1 to the power 3 plus 3 and minor of 3 and 3. Minor of 3 and 3 represents eliminating the third row and third column. Then I'll be left over with these elements, which is nothing but A11, A12, A21 and A22, and finding the determinant of this and multiplying it with -1 to the power 6 gives me the cofactor of this matrix. So hope you all understand it well, and this is a total glimpse of finding the cofactor of the matrix and minor of the matrix. Hope you all like my video, and please subscribe to AT Math Academy. Thank you for taking time to watch it, and enjoy doing math at AT. Thank you.